Hi there, this is Jacob Nash Algebra Lessons, and this is Unit 1, Lesson 5, on continuing our parent functions. And there will be one more video on exponential and logarithm functions, but that's not on this one. Sorry. But on this one is cubic, square root, and reciprocal function. I don't know why I'm saying sorry, because there's still a video, but it's just not on this one. So you'll have to look on my channel for the next one by going on the playlists and choosing Unit 1, and there you go. That's what I suggest doing. If you're trying to watch all my videos, you should go on the playlists. I even have a playlist with all of them, and you can watch all of them before exam. That'll take hours, though, so you'll want to do that a few days in advance. Sorry. I'm trying to go a little bit fast. If you see up here, 18% charge. I don't remember how fast this thing runs out, but anyways. So cubic. What this means, you're going to want to watch lesson 4 before this one, which was part 1 of the parent functions, because you might not understand what they mean. So that means we square the x to get the y, or fx. Or not square, sorry, cube. That's why on Unit 0, Lesson 1, we reviewed our cube roots. So, remember, with the square function, it turns out positive even if x is negative. But this time, if x is negative, it stays negative. Here's why. Because when you multiply a negative by a negative, you get a positive. But when you multiply a negative by a third negative, you get a negative. So there we go. That's why. So what we know is we just take we cube our x to get our y, and it will be negative if x is negative. So values can go below the y-axis this time. Let's look at what that looks like on a graph. So if let's just look. Here's what we can do. So if, let's just say x is 0, we cube it, we get 0. So 0, 0, that's one value. We at least know that. 1 cubed is 1. So we know there's 1, 1. That's another one. 2 cubed is 8. So we know that 2, 8 is 1. 3, 4, 5, 6, 7, 8. And then it's going to be reversed because negative 1 cubed is negative 1. So we have negative 1 right here. And then you can tell that negative 2 cubed is negative 8. So we have 2, negative 8. So let's try to draw this in. So as you can see, it kind of looks like a snake shape. So kind of like this, a little bit. That's what it will look like when there's a cube function. So let's look at a few values. What's the domain? It goes all the way to the left and right. So negative infinity to positive infinity. The range is negative infinity to positive infinity as well. The graph is odd this time. So remember, we said odd meant if you turn this upside down, then it will be symmetrical. So let's see if I can somehow do that. No, I can't. But just like turn your device upside down and see if it looks the same. Yes, it does. So there you go. That's why it's odd. And it is symmetric with the origin, not the y or x-axis, just the origin. There is no relative minimum because it goes down forever. It doesn't ever decrease, it just increases from negative infinity to positive infinity, and it looks like a snake, like I already said. So that's cubic function. Now, let's look at square root function. Interesting. And there are more functions than what I say, but some you'll learn in pre-calculus and, other things like that. So, oh, wrong thing. I was just on that. Square root, that just means whatever whatever x is, you take the square root to find y or fx. So, because once again, fx and y are the same. I think it's kind of dumb that they put that there, but I guess they just want you to do that. I don't know. So, let's say x was 1, take the square root, and 1 would be the y. 4, and then 2. So, you can see how that goes. But there is not going to ever be any negative values so we have here's our coordinate plane. There's positive values here only in this quadrant, so that means when we draw this on the graph, it's only going to be in that one, because there can't be negative values. Here's why. Let's say x was -3. Let's take, what happens if you try to take the square root of -3? You get an error on your calculator because that's not possible. There's no square roots of negative numbers. So you would just have to say imaginary, because that's not a thing. So that's why. So let's look on the graph and see what this looks like. Graph. Okay, so square root of 0 is 0, so 0, 0. Square root of 1 is 1, so 1, 1. Square root of 2 is like 1.41, so like right here. Square root of 3 is like 1.71 or something, and then square root of 4 is 2, square root of 5 is, and then you can see it would go like this, and then 3 and 9 you can see, and then there you go. So that's what our graph looks like for the square root function. It kind of just goes up gradually, but as you can see, that's all it is. It doesn't go into this quadrant, that, or that. So let's look at the values. What's the domain? Well, this time we can't say negative infinity to positive infinity because it doesn't do that. It starts here at 0, so we have to do bracket 0 to infinity. Range is same thing, and because it starts at 0. And we have no symmetry. There's a relative minimum at 0, 0. It doesn't decrease, and it increases from 0 to infinity, and it looks like an arc. That's the square root function. The last one we'll look at in this video is the reciprocal one, and that's a little bit weird. So the only other ones I'm going to be going over are logarithm and exponential in the next video, but I'm not going to go over greatest integers or cube root functions or anything like that, because that's not discussed. Ugh, I did that again. I already was on that. Alright, reciprocal function. That means whatever x is, you put a 1 over it on the numerator, and then that's what it is. So if x is 4, put a 1 over it. X is 44, put a 1 over it. X is 444, put a 1 over it. And that's the y, or the fx. So there you go. We have a lot of strange fractions here, we can tell. What happens if it's negative? Well, it just makes the fraction negative. But what if it's 0? Well, let's see. If x was 0, we would put a 1 over it. Oh, but that's not a thing. You can't have something divided by 0. Just think about it this way. This is what, like, what is it? Siri says this. If you have a whole bunch of cookies and you try to divide it by amongst 0 people, what the heck? No, too bad. Doesn't make sense. So that's called undefined UD, and that's not something that is possible. So you can tell that there's going to be these graphs will not, on the graph, it will never go to 0. It will just go around it. So what will this look like? Let's see. So once again, there's no 0 point. But if x was 1, then we pop a 1 over that, so that's 1. And same thing if it's negative, so we have values here. But then if x is 2, then you pop a 1 over that, that's 1/2. So 2, 1/2. So we go down here. And then same thing for this one, 2, 1/2. And then 1/3, you have 1/3, and then 4, 1/4, 1/5, 1/6, 1/7, 1/8, 1/9, 1/10. And then we do the same thing on here. What could we... There are points up here, though, because think about it. If y was 2, then that means that it was really 2 over 1, and 1 would be x. So you have value here, and then 3 over 1, and then it just goes up and gets smaller and smaller, and it's opposite that way. So the same thing as what we did before. And we can see it's like this. It's like very strange thing. So there's 2 lines that don't even touch on this one, because they can't touch 0 because that's undefined, not a thing. So let's look at the domain range. So domain, what is this? Well, we have to do 2 parts this time. It first goes from -infinity to 0, because even though it doesn't look like it, it goes right by it. And then, sorry about that. Then so you have to do parentheses right there, and then you do U for and then 0 to positive infinity, because it never goes to 0. That's the only value it skips. You do the same thing for this, and there. The graph is odd because that means rotational symmetry. So if you rotated that, it would look the same, upside down. There is no relative minimum because it goes all the way to -infinity. It decreases from -infinity to 0, and then it increases, and then once again to 0 to positive infinity, and it doesn't increase. And the graph, well, what could you say that looked like? I mean, I don't know. I mean, in some parks, like, they'll have, like, a bridge symbol that looks like that. For a bridge, like, you have a path, and then there's bridge because there's water there. I don't know. That's the only thing I can think of. But there you go. That's the last function I'll do on this video. I'm going to do exponential and logarithm. So if you ever seen the thing that looks like ln on your calculator, or log, that's where that comes into play. Well, we actually don't, I'll just talk about that more on the next video. Sorry for the interruption. My little sister came in because apparently it's time for dinner. Whatever. So, yeah. That'll be it for this video. Thanks for watching, and I'll see you on the next video.